Hello and welcome back to our channel. Today we will be looking at blockchain and all of its components. So, let us start off with, what is blockchain? If you have been following banking, investing, or cryptocurrency over the last 10 years, you may have heard the term blockchain, the record-keeping technology behind the Bitcoin network. Blockchain seems complicated, and it definitely can be, but its core concept is really quite simple. A blockchain is a type of database. To be able to understand blockchain, it helps to first understand what a database actually is. A database is a collection of information that is stored electronically on a computer system. Information, or data, in databases is typically structured in table format to allow for easier searching and filtering for specific information. What is the difference between someone using a spreadsheet to store information rather than a database? Spreadsheets are designed for one person, or a small group of people, to store and access limited amounts of information. In contrast, a database is designed to house significantly larger amounts of information that can be accessed, filtered, and manipulated quickly and easily by any number of users at once. Large databases achieve this by housing data on servers that are made of powerful computers. These servers can sometimes be built using hundreds or thousands of computers in order to have the computational power and storage capacity necessary for many users to access the database simultaneously. While a spreadsheet or database may be accessible to any number of people, it is often owned by a business and managed by an appointed individual that has complete control over how it works and the data within it. So, you may be wondering, how does a blockchain differ from a database? The first aspect is the storage structure. One key difference between a typical database and a blockchain is the way the data is structured. A blockchain collects information together in groups, also known as blocks, that hold sets of information. Blocks have certain storage capacities and, when filled, are chained onto the previously filled block, forming a chain of data known as the blockchain. All new information that follows that freshly added block is compiled into a newly formed block that will then also be added to the chain once filled. A database structures its data into tables, whereas a blockchain, like its name implies, structures its data into chunks, blocks, that are chained together. This makes it so that all blockchains are databases but not all databases are blockchains. This system also inherently makes an irreversible timeline of data when implemented in a decentralized nature. When a block is filled, it is set in stone and becomes a part of this timeline. Each block in the chain is given an exact timestamp when it is added to the chain. The second aspect is the decentralization. For the purpose of understanding blockchain, it is instructive to view it in the context of how it has been implemented by Bitcoin. Like a database, Bitcoin needs a collection of computers to store its blockchain. For Bitcoin, this blockchain is just a specific type of database that stores every Bitcoin transaction ever made. In Bitcoin's case, and unlike most databases, these computers are not all under one roof, and each computer or group of computers is operated by a unique individual or a group of individuals. Imagine that a company owns a server comprised of 10,000 computers with a database holding all of its clients' account information. This company has a warehouse containing all of these computers under one roof and has full control of each of these computers and all the information contained within them. Similarly, Bitcoin consists of thousands of computers, but each computer or group of computers that hold its blockchain is in a different geographic location, and they are all operated by separate individuals or groups of people. These computers that make up Bitcoin's network are called nodes. In this model, Bitcoin's blockchain is used in a decentralized way. However, private, centralized blockchains, where the computers that make up its network are owned and operated by a single entity, do exist. In a blockchain, each node has a full record of the data that has been stored on the blockchain since its inception. For Bitcoin, the data is the entire history of all Bitcoin transactions. If one node has an error in its data, it can use the thousands of other nodes as a reference point to correct itself. This way, no one node within the network can alter information held within it. Because of this, the history of transactions in each block that make up Bitcoin's blockchain is irreversible. If one user tampers with Bitcoin's record of transactions, all other nodes would cross-reference each other and easily pinpoint the node with the incorrect information. This system helps to establish an exact and transparent order of events. For Bitcoin, this information is a list of transactions, but it also is possible for a blockchain to hold a variety of information like legal contracts, state identifications, or a company's product inventory. In order to change how that system works, or the information stored within it, a majority of the decentralized network's computing power would need to agree on said changes. This ensures that whatever changes do occur are in the best interests of the majority. Transparency. Because of the decentralized nature of blockchains, all transactions can be transparently viewed by either having a personal node or by using blockchain explorers that allow anyone to see transactions occurring live. Each node has its own copy of the chain that gets updated as fresh blocks are confirmed and added. This means that if you wanted to, you could track Bitcoin wherever it goes. For example, exchanges have been hacked in the past where those who held Bitcoin on the exchange lost everything. While the hacker may be entirely anonymous, the Bitcoins that they extracted are easily traceable. If the Bitcoins that were stolen in some of these hacks were to be moved or spent somewhere, it would be known. So, is blockchain secure? Blockchain technology accounts for the issues of security and trust in several ways. First, new blocks are always stored linearly and chronologically. That is, they are always added to the end of the blockchain. If you take a look at Bitcoin's blockchain, you'll see that each block has a position on the chain, called a height. As of November 2020, the block's height had reached 656,197 blocks so far. After a block has been added to the end of the blockchain, it is very difficult to go back and alter the contents of the block unless the majority reach the consensus to do so. That's because each block contains its own hash, along with the hash of the block before it, as well as the previously mentioned timestamp. Hash codes are created by a math function that turns digital information into a string of numbers and letters. If that information is edited in any way, the hash code changes as well. Here's why that's important to security. Let's say a hacker wants to alter the blockchain and steal Bitcoin from everyone else. If they were to alter their own single copy, it would no longer align with everyone else's copy. When everyone else cross-references their copies against each other, they would see this one copy stand out and that hacker's version of the chain would be cast away as illegitimate. Succeeding with such a hack would require that the hacker simultaneously control and alter 51% of the copies of the blockchain so that their new copy becomes the majority copy and thus, the agreed-upon chain. Such an attack would also require an immense amount of money and resources as they would need to redo all of the blocks because they would now have different timestamps and hash codes. Due to the size of Bitcoin's network and how fast it is growing, the cost to pull off such a feat would probably be insurmountable. Not only would this be extremely expensive, but it would also likely be fruitless. Doing such a thing would not go unnoticed, as network members would see such drastic alterations to the blockchain. The network members would then fork off to a new version of the chain that has not been affected. This would cause the attacked version of Bitcoin to plummet in value, making the attack ultimately pointless as the bad actor has control of the worthless asset. The same would occur if the bad actor were to attack the new fork of Bitcoin. It is built this way so that taking part in the network is far more economically incentivized than attacking it. How is blockchain used? As we now know, blocks on Bitcoin's blockchain store data about monetary transactions. But it turns out that blockchain is actually a reliable way of storing data about other types of transactions, as well. Some companies that have already incorporated blockchain include Walmart, Pfizer, AIG, Siemens, Unilever, and a host of others. For example, IBM has created its Food Trust Blockchain 1 to trace the journey that food products take to get to its locations. Why do this? The food industry has seen countless outbreaks of E. coli, Salmonella, Listeria, as well as hazardous materials being accidentally introduced to foods. In the past, it has taken weeks to find the source of these outbreaks or the cause of sickness from what people are eating. Using blockchain gives brands the ability to track a food product's route from its origin, through each stop it makes, and finally its delivery. If a food is found to be contaminated, then it can be traced all the way back through each stop to its origin. Not only that, but these companies can also now see everything else it may have come in contact with, allowing the identification of the problem to occur far sooner, potentially saving lives. This is one example of blockchains in practice, but there are many other forms of blockchain implementation. Bitcoin versus blockchain. The goal of blockchain is to allow digital information to be recorded and distributed, but not edited. Blockchain technology was first outlined in 1991 by Stuart Haber and W. Scott Stornetta, two researchers who wanted to implement a system where document timestamps could not be tampered with. But it wasn't until almost 2 decades later, with the launch of Bitcoin in January 2009, that blockchain had its first real-world application. The Bitcoin protocol is built on a blockchain. In a research paper introducing the digital currency, Bitcoin's pseudonymous creator, Satoshi Nakamoto, referred to it as a new electronic cash system that's fully peer-to-peer, with no trusted third party. The key thing to understand here is that Bitcoin merely uses blockchain as a means to transparently record a ledger of payments, but blockchain can, in theory, be used to immutably record any number of data points. As discussed above, this could be in the form of transactions, votes in an election, product inventories, state identifications, deeds to homes, and much more. Currently, there is a vast variety of blockchain-based projects looking to implement blockchain in ways to help society other than just recording transactions. One good example is that of blockchain being used as a way to vote in democratic elections. The nature of blockchain's immutability means that fraudulent voting would become far more difficult to occur. For example, a voting system could work such that each citizen of a country would be issued a single cryptocurrency or token. Each candidate would then be given a specific wallet address, and the voters would send their token or crypto to whichever candidate's address they wish to vote for. The transparent and traceable nature of blockchain would eliminate the need for human vote counting as well as the ability of bad actors to tamper with physical ballots. Thank you for watching. If you enjoyed the video, please like and subscribe so not to miss out on more.